Hello students, welcome back to the channel. So today we'll be doing part 2 of chapter 4, that is atomic structure. So firstly we'll understand the representation of an atom in terms of the modern atomic theory. We know that we have the subatomic particles. These subatomic particles are electrons, protons and neutrons. Inside the core of the atom we have the nucleus. And inside the nucleus the atomic mass is there, which comprises of protons and neutrons, and encircling the nucleus we have the imaginary lines which are called as the shells or the orbits, and in these shells or orbits we have the negatively charged electrons which have negligible mass is revolving around these shells or the orbits. Now to represent the subatomic particles, how they will be represented in terms of the charge and mass, we have protons, we have neutrons and electrons. Now the charges will always be written as a subscript. Protons have a positive charge, neutrons are neutral and electrons have a negative charge. This is in terms of the charges which we have shown. Now masses we are going to write as a superscript. Proton has a unit mass meaning 1, neutron also has a unit mass 1 and electrons have negligible mass. So that is how you are going to represent the three subatomic particles with respect to their charge and mass. This is important. At times they ask you to write this in the examination. Next we have the periodic table, that is a modern periodic table. We know as of now 118 elements have been discovered, and this table is representing the elements which are arranged in increasing order of their atomic number. Very, very important. In increasing order of atomic number, the elements have been arranged. Okay, so this can be asked in your MCQ, how the elements are arranged in increasing order of their mass number, atomic number. So you need to remember elements are arranged in increasing order of their atomic number, and this table was given by a scientist by the name of Mendeleev. Okay, his name is important. Okay, double E and double F, Mendeleev. Mendeleev was the scientist who has given this modern periodic table. Now for class 8th, you need to know the first 20 elements. So I'll just highlight these first 20 elements. We have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. So these are the first 20 elements which you need to remember. Okay, now if we take the example of an element nitrogen, nitrogen has an atomic mass of 14 and atomic mass number 14 and atomic number is 7. Okay, so in this case, if I have to represent the mass number, you will always remember that mass number is written as a superscript, capital A, and atomic number is written as a subscript, that is capital Z. Okay, so this is what you need to remember. The symbol of the element, where is mass number written as a superscript and the atomic number is written as a subscript. Okay, now coming on to the atomic number of an atom, of an element, it is represented by capital Z, and the relationship is Z is equal to P is equal to E, where P is the number of protons and E is the number of electron. So what is atomic number of an atom? It is the number of protons in the atom of an element, and because atoms are electrically neutral, we say number of protons is equal to number of electrons. Now here we have the example of the atom of carbon. Now carbon has a mass number 12 and atomic number 6. Now when these values are given, it becomes easier for you to calculate the number of protons and electrons, because we know that the atomic number is 6 What will be the number of protons? 6. And because the number of protons is equal to electrons, so the number of electrons will also be 6. So when you know this relationship, then you can easily identify the number of protons, electrons that are given. Now to calculate the number of neutrons, the formula which you will remember is mass number minus the atomic number. Mass number is how much? 12. Atomic number is 6. So the number of neutrons in the atom of carbon will be 6. So like this, simple questions can be given in the examination where you have to calculate the number of protons, electrons and neutrons. Next we have the mass number of an atom. It is represented by capital A, very important. How will you remember? In the word mass you are having letter A. So keeping that in mind, that the word mass has a letter A, you will remember that mass number is represented by capital A. And what is mass number? How will you define? Mass number of an element is equal to the total number of protons and neutrons, and where these protons and neutrons are present inside the nucleus. So where is the mass of an atom concentrated? Inside the core of the atom, that is the nucleus of the atom. And now we know that electrons have negligible mass. So the total mass of an atom is the mass of the protons and neutrons. So here also we have the example of carbon. So we know that the number of protons is 6, number of electrons is 6, and if mass number is given, mass number is 12, how will you calculate the number of neutrons? Neutrons we can calculate here. If you have to calculate the number of neutrons, we know the mass number and we know the protons. So number of neutrons you can also calculate like this: A minus P, that is mass number minus the protons. So the number of neutrons will be 6. And the other way of calculating the number of neutrons is the formula of mass number minus the atomic number. Mass number is 12 of carbon and atomic number is 6, so the number of neutrons is 6. So always remember atomic number and mass number. Atomic number you know, mass number will be given in the question. So you need not learn the mass number of the elements, mass number will be given. So based on that you can easily calculate the number of protons, electrons and neutrons. Next we have two important definitions. Now to calculate the mass of an atom was very challenging for the scientists, because atom is very small. It is so tiny that to weigh it directly was very difficult. So scientists started comparing their weights to some standard element. So earlier hydrogen was taken as a standard because it was the first element and the lightest element, hence it was taken into consideration. But now later on carbon has been taken as the standard element. So accordingly the definition states that it is equal to, the relative atomic mass is equal to number of times one atom of an element is heavier or is heavier than the mass of an atom of hydrogen. Okay, so it tells us how heavy one atom of an element is when we are comparing it with the mass of an atom of hydrogen. So for example, imagine you don't know your weight, but you compare yourself to a friend. If you're 3 times heavier than your friend, then your relative weight will be 3. So for example, if carbon atomic mass is 12, oxygen its atomic mass is 16, then what we can say that oxygen is 16 times heavier than carbon, so its relative atomic mass is more as compared to carbon. So that is how, with the simple example, you can understand what relative atomic mass is. Then what is relative molecular mass? It is equal to number of times one molecule of the substance is heavier than the mass of an atom of hydrogen, or we also say it is heavier than 1/12 the mass of an atom of carbon. Okay, so when we are talking about relative atomic mass, it is mass of an atom, and when we are talking about relative molecular mass, it is in terms of mass of a whole molecule. Mass of a whole molecule. Okay, so here if we take the example of calculating the relative molecular mass of water. What will be the relative molecular mass of water? Hydrogen, we know its atomic mass is 1. Oxygen atomic mass is 16. So let's substitute the values over here. 2 into 1 plus 16. What will be the relative molecular mass of water? It will be 18. 18 will be the relative molecular mass of water. So for class 8th, definitions are important. You might be asked to define relative atomic mass or relative molecular mass. So please learn the definition as it is given in your textbooks. Okay, moving on to the next part, that is distribution of electrons in an atom. We know that electrons revolve around the nucleus in imaginary paths, which we call as orbits or shells, and we have different orbits. We have k orbit, l orbit, m orbit. Now to find out how many electrons are there in each shell, we use the formula 2n square, where n corresponds to the number of the shell. So k shell is first shell, l shell is the second shell, and m shell is the third shell. Now to calculate the number of electrons in each shell, we will use the formula. In k shell, how many electrons will be there? 2 into n square. N is how much? 1. So in k shell, 2 electrons will be accommodated. Then in L shell, how many electrons can be accommodated? 2 into 2 square. So here 8 electrons will be accommodated in L shell. And lastly in M shell, it will be 2 into 3 square. 3 3s are 9, 9 2s are 18 electrons. Now for class 8th, please remember you have just the first 20 elements to remember, and because of the first 20 elements, you will follow just two basic rules. The first shell will have 2 electrons and the outermost shell cannot have more than 8 electrons. That is the rule which you will be following. And when you'll go to higher grades, there you'll understand the concept of subshell. So the subshell is not there for your ICSE syllabus. Please be very clear. Don't get confused. Only you have to stick to the first 20 elements and the simple filling of electrons on the basis of that the first shell will accommodate. Like for hydrogen, its atomic number is 1. So its electronic configuration will be 1. But if I take the example of, for example, sodium. Now sodium's atomic number is 11. So its configuration will be, first shell will have 2 electrons. Now the second shell can have at the most 8 electrons. One extra electron which will be there, it will move to the third shell. So that is how we write the electronic configuration. If you write the configuration as 2 9, this will be considered wrong, because the second shell which is there, you cannot have more than 8 electrons. It follows the complete octet rule. Once 8 electrons are filled, the octet is complete, then the next whatever extra electrons will be there, it will move to the next shell. Okay, so that is how the distribution of electrons will take place in atoms. And for first 20 elements, we have the simple filling of electrons. We don't consider the concept of subshell in ICSE. That you will study later on. So please be very clear on that. Lastly, coming to the definition of isotopes. What are isotopes? These are atoms of the same element. So here we'll be considering the isotopes of hydrogen. Okay, hydrogen we'll be considering. Same element, same atomic number, but what will be differing every time? Mass numbers. So the first isotope of hydrogen, it has mass number 1. Second isotope, it has mass number 2. And third isotope has mass number 3. So definitely when mass numbers are different, what is going to differ in all the 3 cases of isotopes of hydrogen? Just think, what is going to differ? Yes, the number of neutrons are going to differ, because we calculate neutrons by subtracting mass number from the atomic number. So protons and electrons will remain the same in all the 3 structure or in all the 3 isotopes of hydrogen. In the first case, the first isotope of hydrogen is protium, that is the name of the first isotope. Number of neutrons here will be 0. Okay. Second is deuterium. Deuterium, that is the second isotope of hydrogen, and here the number of neutrons will be 1. And the third and the last isotope of hydrogen is tritium, and in this case the number of neutrons will be 2. Okay, so in all the three cases, which subatomic particle is differing, that is the number of neutrons, because the mass numbers are different. Hence, when we calculate the number of neutrons are going to differ. So, for your examination point of view, definition is important and the example of hydrogen is important, where you might be asked to draw the isotopes of hydrogen. You might be asked that which subatomic particle is differing in the three isotopes of hydrogen. So you should be clear that the number of neutrons will be differing in all the three isotopes of hydrogen. So for today, this much only we are going to see in the second part of the video. In the next video, we'll be seeing the arrangement of electrons, that is, we'll closely see the electronic configuration of the first 20 elements, and we'll also see the valency and bonding. So see you in the next video.